and thanks to all organizers for organizing this event. Also, I want to say thank you to sponsors. Without them, we cannot really have events like this. So I'm going to speak about SQL Server's new features for devs and analysts. Usually that's talks are about the mostly DBAs, but I have one for devs. So I'm hoping everybody's gonna learn something new today. Let me speak about myself first. I'm Hasan Savran, and I am from Cleveland, Ohio. Currently, I am working for Progressive Insurance as business intelligence architect. I have some good experience with development, and I started with the business intelligence 7 years ago when I moved to Progressive. So I started to kind of see the both sides, I guess, with the devs and the DBAs and the business. So that gave me some kind of, experience, and I tried to kind of understand the both sides and try to explain the both sides how things can be confusing for devs and DBAs. You can follow me in the following environment. I'm pretty active in Twitter and LinkedIn. I have a blog. Usually I try to write once a week. And I write about C# front end, SQL Server, Cosmos DB. I like to share. So, and also I'm a honored Microsoft Data Platform MVP, and this is my first year with them too. So I'm going to have a lot of features I'm going to cover today. So if you all have any questions, please follow me from any of those areas, and I will be happy to, answer any of your questions later. Here's our agenda today. I'm going to start with Linux support. Then we are going to move to graph database tables. I'm going to try to explain why you might need them and how can we use them. I will show you how to run the machine learning scripts in SQL Server. Then we will move to the JSON, which is loved by devs and usually hated by DBAs. And I will try to explain how to use the JSON in SQL Server. And we have memory optimized tables, which is not really common, unfortunately, but devs should use it because it has a lot of advantages. So I'm going to try to show you those advantages. Temporal tables are great for auditing. If you worry about the history, if you want trending, temporal tables can be really useful for you. And we will finish today with clustered Columnstore indexes, and I will try to explain why you should use them. So let's start with the Linux support first. Linux became available, I guess the SQL Server on Linux became available in 2017. And if you want to install SQL Server on Linux directly, you are going to need one of those operation systems you see. The numbers under them that's the minimum version number you must have if you want to install the SQL Server directly to the Linux operation system. If you have any other operation system rather than that tree, don't worry, you have an option. What you can do is actually you can go to Docker and get the container version, and you can run that version in any Linux operation system, even it's not listed here. And I believe the Docker version is Red Hat, if I remember right. So I'm not going to go that much details about the Linux version. All I want to actually, cover here is what is available and what is not available. If you are thinking about the Linux version, the list that you see here is for 2017. And as you can see, if you are thinking about using the Linux in production for SQL Server, I will really focus on the right side rather than left side. Left side has some of the features which is available. I try to list some of the common ones. But the right side actually is the most important one. You kind of need to ask yourself, can you survive without any of those features and services? For example, there are some big items here. There's like reporting services, analysis services. Those are pretty important for my customers. I don't know about you. And without them, I really cannot survive in Linux environment. As you know, the 2019 came up last year. So actually 2019, some of those items became available. So now we have machine learning services, replication support, and holidays actually supported in SQL Server 2019. As you can see, the reporting service is really kind of bothering me because I'm kind of depending on that, and I really cannot do that much without that. I have a lot of SSRS reports. I have a lot of analysis services. So if you are thinking about moving to Linux, I will really focus on the right side, not the left side. Next item I'm going to cover is graph database tables. Graph database tables are not new. They have been out there for some time now, and they are introduced to SQL Server in 2017. So what can you do with them? I guess before we go in details, like how they work and other stuff, that's the best, I guess, the information I can give you is, do you really need them? So graph database tables, in this time, the things are changing very quickly. And whenever a business logic changes in your environment, or the business something changes in your business, usually your data changes. When your data changes, you might need to actually revisit your data model. And you might need to change, I don't know, you might need to add new tables, you might need to add new relations, new columns to actually support that. Your business might be selling X, and they say that, you know what, I'm going to sell Y, and your data model needs to kind of support that. And you need to create some data models which should be flexible. It should be easy to create new domains, or it should be easy to add new relations to those tables. That can be a challenge in relational database tables because, well, it's much easier to kind of know what the problem is and come up with the data model. When you actually introduce those changes later, you might have some problems, some issues. Yeah, I mean, it's pretty easy to add new tables, new columns, new relations. But the problem is, usually when you create those new tables, that means more joins. More joins means, well, usually the things are going to get slower. You like it or not. So this actually picture here is representing, I guess the highway represents the tables, right? So if you are actually, let's say you are going on this highway and you want to jump here, you cannot just jump here. You need to, I don't know, depending on the highway, I'm not sure how many curves you need to take it to go here. If you are going with 100 miles, guess what? You like it or not, you are going to slow down for the curve. And if you have many curves, it's going to take some time to get that data to reach there. Graph database tables actually kind of has some features that, you know, it makes your life a little bit easier. Also, in regular relational databases, you cannot really have many-to-many relations between two tables. You need to create another table, junction table, which is going to contain your primary keys, your foreign keys, and you're going to be able to make many-to-many joins because of that. That means more joins. In graph database tables, it's not like that. So graph database tables has some advantages. And as I said before, it has been used in many places. It's just introduced to SQL Server. So who's using them? The first one I can give you is suggestion engines. Any kind of big application you go right now, they like to suggest you stuff, right? So for example, you go to the Amazon and you are looking for something. And when you scroll down, usually Amazon starts to suggest you like, oh, you know, like, okay, you like this product, but I have other products just like this. Or people are buying this, also buying that. So those are very useful. And sometimes because of that, I find a better product that, you know, I was looking for. And customers are expecting that now. So the problem with that is not really an easy query if you think about it. If you're using SQL Server, all you have is a product ID. And by just knowing that product ID, you're supposed to go and find what other people are buying other products just like this product. That sounds like a nightmare to me. Like especially if you had OLTP, if you are not using NoSQL, that's not going to be an easy query. And also, but don't forget, if you're a big company and if you're a web developer, your application should render your page in 3 to 5 seconds max. So you are going to get all that data and also all those suggestions probably in 1 second. Then the page can be rendered and go to the user. So graph tables actually works for that. Let's give you an example, right? So you want to learn, I guess everybody talks about the Kubernetes, right? And everybody's saying, oh, this is the feature, and everybody's going to use this, and you kind of panic, and it's like, oh, you know what? I need to go and learn this right now. And you go to Amazon, and you start to look for a book to learn it. You find a decent book, you open the page, there's a screen, it shows the page, it shows you the price, you scroll down and you see there's some description, reviews, and you end up with something like this. Says, well, people are buying this, also buying that. So to make that happen, graph tables can actually help you with that. Second one, which also, this is not really real, it's just a joke. I just want to be sure that make that clear. That was not a real. Second one is governments, or maybe hospitals, I can't tell. So in those, I guess, environments, you have many agencies. In hospitals, you have many patients. So what happens is, if you're a government agency, and let's say you have a social security of somebody, and you just type it and searching for it, you end up with a lot of records of same person from different agencies. So you need some kind of like an MDM, which is a master data management system. So whenever you search by the social security number, you want to see only one item. You don't want to see one per agency. So you need some kind of merging system, which is going to take all those entities and make one entity. Same with the healthcare. If you are a doctor looking for a patient, your patient might visit many hospitals or with the same hospital but different medical numbers. So you need a system which is going to take all this information and merge it in one. Graph database tables is great for that. Last one I'm going to give you an example is a Facebook or any other social media, really. If you think about Facebook, what do you do in Facebook? You usually go there and you like things, right? So you are the user, which is the entity, and you like, I don't know, a post, you like a picture, you like an image, you like a shop. So if you think about it, entities changes, but relation is same. It's the same relation. So unfortunately, you cannot do that in relational database tables. You have foreign key, you have a primary key. That's all you have to make a relation. And you cannot create a dynamic relations the way that I explained. Graph database tables can do that. And to do that, they use a different type of table. So there are two table kinds in graph database tables. And they make really the relation a first-class citizen. So they have their own tables. Here's more information about them. So there are two types of tables. First one is the node tables, which contains the entity information. And edge tables they contain the relations. So let's start with the node tables first. Every node table, every row has a node ID. That's a virtual column, and it's the identity of that entity. You really cannot do that much with node ID. You cannot update it, you cannot delete it, you cannot do anything. Every time you insert something there, node ID just gets populated. And if you actually go and say select all from a node table, you will see that that node ID column is a JSON object. Also, those node tables can have any type of columns. So any data type SQL Server supports, you can actually create them in the node tables. Edge tables are interesting. That's the one that actually contains all the relation tables, all the relation information. Just like the node tables, we have an edge ID. Edge ID is the identity of a relation. Just like the node ID, you cannot change it and you cannot update it. You cannot do anything with it. It's just another JSON object if you actually write a select all from an edge table. Edge tables has two other virtual columns, which is the from ID and to ID. So to make a relation, you need at least two entities, and from and to IDs actually contain other node IDs from other entity tables. Very interesting feature of edge tables, they can have any type of columns. That means your relations can have attributes. In regular relational tables, you cannot do that. It has to be in the entity table because that's the only option you have. Because of that, sometimes your table gets, grow and end up with 100 columns. In this way, your tables, you can actually separate those information. Relations cannot be updated. So if you create a relation, you cannot just change it. You have to drop it, and you have to create a new relation if you need to insert a new one. Directions are important. So what I mean with that is, let's say we have a users table. Users table is a node table, and let's say we have another table named like. So we have a username Alec, and we have another username Anna, and we want to say Alec likes Anna. So to do that, we just take the node ID of Alec and put that in the from ID of like table. We take the Anna's node ID and put that in the to ID in the same row. That creates a relation between Alec and Anna. Alec likes Anna. Directions are important. That means Anna might not like Alec back. So that's what I mean with the directions important. Another example on top, as you can see, so we have 3 node tables here and 2 edge tables. The way that I was explaining to you that product, let's say we are the e-commerce and we have those products. Our user goes to Kindle Fire product page, and as soon as they hit it, I can run a very simple query and find all the other products like Kindle Fire. And I can just suggest that just like Amazon in the bottom of that page. It's pretty easy with the graph database tables. To do that, we need to know this new match clause. You have to use that in the where clause, and it takes a graph search pattern. This pattern must have at least 2 entities and 1 relation. And it needs to go from one entity to other entity using a relation. So that means we are using at least 3 tables. This thing can get a little bit complex. To make that a little bit clear, you need to use the parentheses to remark the relationships, because usually you use the aliases, and then that will make kind of, I guess, easy to read that match clause. Also, we use the arrow character to specify which direction we are going. So there is a lot of information here. It might sound maybe a little bit complex, but not really. Here's an example. So in here, we have 3 tables. We have product table, user table. As you might guess, those are the entity tables. And we have a wished table. So as you can see, my match clause is going from users table to the products table by using the wished relation. And I'm looking only user ID 1. That's going to give me the user ID 1's wish list if I use the graph tables to handle that. And this match clause can get complex. You can use and, or anything like that in here. Now, let's see actually how that thing works in real life. So I have some examples here for you. Let me put my SSMS. All right. So the first of all, I don't know if you know, this is very useful for me. Drop table if exists. Short name is die, D-I-E. If it exists, it just drops it. So I'm going to do this first and start from scratch. So I'm creating a users table. I have a primary key. There's really nothing different here, but only at the end, I'm just saying adds node. That makes this users table a node table, which is an entity table. I have another table named products. So I have a bunch of attributes, which is the columns. It supports all of them here. And I make this table an entity table too. Then I create some relation tables. As you can see, I can actually put any attributes here. On here, I just add the created date, so I will know when I create this relationship between the entities. Also, Microsoft strongly suggests you to create indexes in from ID and to ID here, because even we don't use it, but the system uses it to find the data. So that will create an index, so we don't need to scan the whole table if we do this. Also, I use another table, relation table. As you can see, is I put as age, and I just want to track the date. And again, I'm just creating an index on it. So I'm just going to run the whole thing here. Everything went good. Now, let's insert some data. As you can see, really, there is nothing different. the insert, I just insert into my product table, which is my entity table, and I just insert those columns. There is absolutely nothing change to insert or update any data to these tables. So let's actually insert some data to our entity tables. So it looks like I have 9 products and 12 users. If you look at the data, what it looks like and you will see the node ID, as I said before, it looks like a JSON document. And if you actually go and see here, let's see, I think I use the graphs database. If you look at here, you can find your tables under graph tables. Here they are. So I have a bunch of graph tables here. So they will be under the graph table folder. So let's continue here. Next, I am going to insert data to relation tables. So in here, as you can see, my alike product, I need 2 products here, and I'm picking product 1, one's node ID, and 2 nodes ID here. This one goes to the from ID, this one goes to the to ID. And I'm passing the get date because, as you remember, we created the credit date, so we will track when we create this relationship. So this one is going to create a bunch of relations between products. In second one, as you can see, I have another relation table, which is going to have the wish list of users. As you can see, it accepts 2 different entities. It doesn't have to be the same exact entity. So that means dynamically, really, you can create any kind of relation between any entities. So this is going to create user ID 1, wishes, product ID 9. And this is the time or the date that we actually created this. So I'm going to insert all this data, then continue. Next one is the match, which is going to actually find the data. So to find the data here, I'm just using the match. I'm using my products table twice, and I'm using the alike product. So product is going to the other product using the alike product, and I'm looking only product ID 1. Run this, and looks like I have Kindle Fire 7. It's $49. It looks like I have another product like this one, and it's $79. So whenever a user goes to this page, I can easily show what other products I have in my database. So as I said before, match can get complex as much as you want. So in here, looks like what I'm doing here is I'm using a bunch of tables here, users, products. So what I'm really doing here is I am looking the ANOS wish list. And if any of the items might not be available, then I can actually show them what is alike product in that wish list. So I'm going from the users table to the product table by the wish table. This is going to give me the wish list. And as you can see, this is going to the right side and this is going to the left side. So in here, the product is going to the other product by using the alike. This is equal to this one. So if you want, you can use it and if that makes sense, or you can just use the arrows here to actually define the direction. So this is going to give you user IDs 1 wish list, which is, I guess she wished Kindle Fire HD8 and iPad 3. Well, we have other products like in here. So you can make this as complex as you like. The last one, which is very interesting one, which I'm going to try to go this one fast. So in here, I have product table, warehouse table, users table, in stock table, and in process table. The product table is a node table, and those are my warehouses. Those are my products. All the users are here. As you can see, I'm actually tracking the geolocation of the users. And in stock is telling me what is in stock. It's a relation table. In process table actually has the information whenever I sell something, it goes in here. So user has a relation in process relation between the product and the user. So I know who is buying what. So the next, I'm putting some products in my tables, some users in my tables. As you can see, I'm passing geospatial data of the location. It doesn't have to be a pinpoint. It can be somewhere in Kansas City, really. So it really doesn't matter. because usually you don't know exactly where the person lives. And the next one is my warehouses. Those are my warehouses, and those are the warehouse locations. And from here, I am creating some data between the products and the warehouses. This one tells me which product is available in which warehouse. So next, it creates all kind of product and users in process. Okay, 1 minute here. That was the in stock. Next one is the in process, which actually shows me the relations between the users and products. So that means that this user is buying this product, and I'm in process to actually send this product to my user. So let's run this first. This is the structure, and talk about what we can do with graph tables. Now I have my tables, hopefully, and I have all kind of data in them. So now I'm ready to query this. By using the geospatial data and graph tables, what I'm going to do here is I'm going to actually just run and find which warehouses has which product. So when I run this one here, this is going to give me, for example, here, this is user ID George. He is from Virginia Beach, and he is buying 27-inch monitor. Looks like this product is available in 3 warehouses. And I'm using the window function here to figure out which one is the, well, shortest to George. So I will send the data, or I will send the 27-inch monitor to him from wherever is closest. So it will be much cheaper for me to send this to him. If I run the whole thing here, it's just gonna pick the number 1. So it looks like George from Virginia Beach, 27-inch monitor is coming from Minnesota. So I can go and analyze this data for all of my users. And if there's a lot of people from this area buying the 27-inch monitor, maybe I may need to actually, I guess, move this 27-inch monitor to somewhere close to the George. And as you can see, all I did is really, I did a match between the user to the product. And this is the in process. That's the users bought this product. And this one is the one going from the warehouse. So do I have this product in which warehouse? So you can create all kind of items with the graph database tables. You can get more information about this in my blog. There's more information step by step how to use this. All right, let me continue. Next one is machine learning. Machine learning is, well, is introduced to SQL Server in 2016. And it used to be named R services because it only, I guess, run the R scripts. It was available on the Windows environment. 2017 came and Microsoft changed the name from R services to machine learning because they introduced a new language that SQL Server can run, which is a Python. Now in 2017, it can run R scripts or Python. And it was still available only in Windows. In 2019 came and we have another language, Java, and SQL Server can run the Java. And the big change was now machine learning services actually available in Linux. So you can run Windows and Linux. I'm sure you are asking now, okay, what about the faces, right? Those are our DBAs. DBAs do not like them, and they have good reasons. The first reason is, whenever I ask, is, well, do I need to learn all those languages right now? How am I going to debug this? And the second one is, well, I don't want this on the SQL Server machine because I cannot monitor it. Most of the, the monitor systems that they have been using, if you haven't updated yet, well, they have absolutely no idea about the machine learning services, and you cannot monitor it, which is a good kind of, I guess, excuse to not use the machine learning services. At least I got that from my DBA whenever I tried to actually turn the R services on. So I say, okay, what can we do about that? What is available? If you don't want to actually spend money, I'm not even sure that if products actually is monitoring them right now, so I'm not even sure. But what I found is those reports. Those reports are from Microsoft. They are in a GitHub. You can get them from those two locations, depending which SQL Server version you have. And they give you some kind of information. Yeah, they don't give that much, but they give you something. So those are custom reports. You can take them and put them in the SSMS reports. And you can just right click on the custom reports and run that, and it will show you all kind of information about those services. As I said before, it's not perfect, but it will give you some piece, like it gives you the execution statistics, which packages are installed. So something. So that might be the first step to actually go and look at it. And if it's not enough, you might need to actually upgrade your dashboard, whatever you are using for SQL Server, or you might need to buy a new one to turn this on. Now, let's actually see how this thing works. Let's go back to the SSMS here. It's pretty simple. So there's a one store procedure here that you want to run, and let me actually find here. So to run any R script, Python, or JavaScript, you need to run this store procedure. And you need to pass a couple of variables. The first one, I'm passing the language. In my case, it's R, but it can be Python or Java, depending what you want to run. The second one is the script that you want to run. This script is R script. And it's pretty simple right now. All it does is really, it puts them in a frame and it sums the number that I'm sending. And there are two names here. Output data set is the one that when it's done, it will send it back to the SQL Server, so you will see it. Input data set is what I'm going to actually send to our script. So this is what I'm actually sending. This is the input data. So if I run this, so looks like this is the data I'm sending, bunch of names and bunch of numbers. This is gonna do really sum this up. So, and it's gonna return me, since I'm using the with results, it's gonna return me then as a number, integer number. So let's run this one. And when you run this first time, it takes a little bit longer, but as you can see, I end up with the number integer. This can get complex as much as you want, and as long as it's a valid R script, Python script, or JavaScript, it should run. That's really it for the machine learning services. That's all you need to know is the store procedure here. All right. Next is JSON. JSON was introduced in SQL Server 2016, and JSON is, well, devs love them, and most of the DBAs do not. I guess one of the main reasons DBAs do not like it is because there's no JSON data type. And Microsoft suggests that you should have varchar max or nvarchar max for JSON. Just reading and hearing that is just a red flag itself. But really, you don't have to, right? If your JSON document is smaller, you can make it varchar 200 or 2000. That will help. And it came up with some of those functions, as you can see here. And they came up on 2016. I don't believe there's any updates on 2017 and 2019 to the JSON features of SQL Server. IsJSON is one of the functions. It just checks the given JSON document is valid or not. JSON value will get a value from the JSON document, and it will return only that value. JSON query will query the JSON document that you pass, and it will return the data as JSON. JSON modify, as you might guess, it just modifies the JSON, and OpenJSON can open the JSON from another variable, file location, network location. Well, if you have writes, I guess, but you can do that for that. And for JSON is just like for XML. When you do that, it returns the data as XML. In for JSON, returns the data as JSON, which is a great function actually that you can do all kind of stuff. So let's look at what we can do with that. First, let's do that from the SSMS. So let's go to JSON query. And I'm just using the white word importers, and they have actual JSON data there. So let's look at, this is the data we're gonna play with. It's just, as you can see, it's JSON. First, I'm gonna demo the isJSON. It's gonna just return true or false. And I'm used to F10 for this. Okay, here we go. When I run that, that's a valid JSON. Next one is the JSON value, and this is the query that I'm passing, and this means the root of the document, and I'm looking for the delivered when property. When I run that, it just returns it as varchar here, and even this is at datetime, it will be a varchar, so you're responsible to convert that if you need to. Second one is the JSON query, and that events here, this is actually another object in JSON. So it's gonna return me a JSON object, as you can see. Next one is JSON modify. So I'm gonna modify, make sure the JSON query, and this is gonna query the events here. I think I just did that. My keyboard is kind of acting up, sorry. Okay, let's go to the JSON modify. So in here, I am actually updating the receive by SQL Server LA. When I do that, actually it's not gonna update it. It's gonna return it as updated because I'm not using the update here. So really this is gonna just select it and change the receive by to SQL Server LA. If I want to change it in SQL Server, I need to use the update. So I'm updating the invoices, and I'm just taking this JSON and put it back in the same column name. So when I do that, it's gonna actually update it. And if you want to see if it's updated or not, I can go and use the JSON value again here and see what is the value. So you can see SQL Server LA. Next one. So as I said before, the things comes up as string or varchar from the JSON value. We can use the open JSON and we can use the with that. And that means we can actually change the data type. So in here, for example, I'm getting the receive by and I'm returning as varchar 20, and I'm getting the delivered when, and I'm getting the data. So if I run that, then I have actually the names right, alias is right, and actually the data type is right. So I can do that. Next one, very powerful one, is the for JSON auto. So if I run this one as it is, as you can see, it's a tabular data, and I have their data types. By just actually adding this to for JSON auto and without array wrapper, I end up with a JSON object of this data. So this one is pretty important for devs. So because what we can do in MVC with this is you can actually create a store procedure and then actually make it return as for JSON. So that means you can get rid of your ORM by just using that. How to do that? Let me have another demo for you for that. So I have my Visual Studio here. So as you can see, I am loading a product and I'm using my connection, whatever the connection string is, and this is the store procedure I'm running. This store procedure actually has that for JSON in it. And everything works as it is. I'm just passing a product ID here. And all I'm doing here is, as you can see, I'm using a JSON serializer, and I deserialize the JSON that SQL Server actually returns. So that means what actually ORM is doing, I am doing this manually, and SQL Server is helping me. So to demo this, let's see. Here's my web application. And I'm gonna go to product, and I'm looking for product ID 1. When I run this, it's gonna return here, and it's gonna say, okay, let's debug this. So I'm going in here, SQL comment is store procedure. This is my parameter, which is 1. I create my data set. This is my adapter. I fill my data set. And as you can see right now, the converted is null. If I run this, my converted becomes an object. And it fills as long as the column name is matching, everything should match perfectly. That's exactly what Entity Framework does for you. And you can actually if this is the only reason you are using the ORM, you can get rid of ORM and probably make your DBA happy by just doing that. As you can see, I see my data here. So JSON can be DBA friendly, I guess, right? Anyway, now let's continue. We have 20 minutes left. The next one I'm going to cover here is memory optimized tables. Memory optimized tables has been out there for some time, but many people believe that they are buggy, and was one of the main reasons that DBAs do not want to use them. So there are, I believe they are much better in 2017 and 19. Microsoft has been working on them, and I think they are very stable right now. So I don't really have any kind of problem to, I guess, suggest to use them, especially if you have 2017 and 19. So there are two types of memory optimized tables. The first one is durable tables. Durable tables, when you store the data is getting stored in disk and the memory. So whenever you actually go and select the data, it comes from the memory. It's already there. So it's pretty fast. If you need to update and insert, SQL Server updates it in memory and the disk together. They are much faster than file tables, but they still need the disk. Second one is non-durable tables. Non-durable tables can be interesting because the data is stored only in memory. You have absolutely no business with disk. They are much faster than durable tables. And well, whenever your SQL Server goes down, guess what? Your data goes down. So now you might say that, why do I need any table like that? Non-durable tables are great for caching stuff, right? If you need to cache stuff, you don't really need to put them in disk. And if you can cache, if I can get rid of like products like Redis, memcache by non-durable tables, I will be happy. I still use the select statement, and I don't need to learn a whole new, I guess, language to use Redis or memcache or whatever you are using for cache. And it's still in SQL Server. And that's one of the main reasons that I really suggest to devs to use SQL Server for caching. And they can be really, really fast and, well, very friendly for devs. We also have another option for the mem tables. If you are using mem tables, native compile store procedures even make them even faster. This type of store procedures are available only for memory optimized tables, and they do not support all the T-SQL. So the things you can do is limited. And whenever you create them, SQL Server compiles them and creates a small application and puts them in the memory. That means your data is in memory and your application is in the memory. And as soon as you hit it, you really end up with the data in milliseconds. The SQL Server puts them as a DLL in this folder. So if SQL Server goes down for any reason and it comes back, it compiles all of them and puts them back to the memory. And they can make things even faster if you use them. In 2017, Microsoft came up with all these changes for the memory tables. In 2019, I don't think they had any kind of changes for devs to use. The first big one was JSON support. That means it supported the LOB columns. Cross-apply, top-end with ties, and case support, those came for the store procedures. That means actually memory optimized tables can run those statements. Computed columns were a big one, and they come up with the no index limit. So no index limit is, I guess, touchy for me because many DBAs believes that it's not really a good idea to have no index, because I see in Twitter many times that, oh, you know, I see this person has 100 columns in it and there's 99 indexes on it. If that is a bad thing to do, maybe we should not give devs a no index limit. That is my, I guess, idea. Anyway, so we have SP rename and SP space used. Those are the, you know, DBA friendly stuff, and you can use them for the memory optimized tables. The tricky part is here when we combine them together, you end up with something really interesting. The first thing is if you do the JSON support, computed columns, and no index, you almost create this NoSQL environment in SQL Server. And if you think about the Redis, for example, in Redis, you have a key, you have a value. You must know your key to get the value. It's almost like your key is primary key. So not all the time that you have the primary key to get the data. But in SQL Server, you can do very interesting things here. First of all, you are using the T-SQL, and you don't need to know the key. You can actually, by using the JSON functions, you can actually search by the value. So let's see that. How can we do that? Let's go back to SSMS. And we are going to do the JSON in memory. So in here, what I'm doing here is I'm creating a summaries table. And it's pretty simple. I have an ID, which is the key if you compare to Redis, right? This is the primary key. So if you know that it's going to be fast. My summary is JSON document. And I'm creating a table, a column here named driver ID. It's a computed column. It's coming from my JSON object, driver ID, and it's an integer, and it's persistent. So it's always there. On top of that, I don't stop there. I say, well, I want to index that too. So this is a really good structure here. If this is driver ID is a very common way to search that, it's going to be pretty fast. By doing that, I'm making a memory table. And by putting the drawability schema only, I say I have no business with disk. I want this data in memory, and that's it. So let's run that. Let's create our table. Then I say, okay, since I don't have the JSON data type, there can be any kind of varchar here. And that I don't want that. I want to create a constraint here. And I want to say is JSON is 1. So that means whatever I insert here, I want to be sure that it's JSON. So let's do that. Then I insert some data. Let's do that too. So all that data is actually going in my memory right now. And it looks like I have, let's say, 71,000 rows. Let's make it easy. And now, if I know the ID, well, you bet that's going to be fast because I'm using the primary key, right? It's fast. So let's actually do this one here. Let's go to the second one. So second one here, I'm saying, okay, I'm looking for driver ID 2. And since this is a JSON, a string, I'm just passing string. So I'm thinking this should be fast. When I run that, I'm looking 71,000. Well, it took 3 seconds. It's not bad, but if you look at the execution plan, I'm doing a table scan. That's not good. Just because of that, I create an index here, but I'm not hitting it. The main reason I'm not hitting it because it's an integer. So if I actually change this to an integer and run this again, let's try again. And as you can see, 0 seconds. Execution plan, I hit the index. Oh, I'm happy. Everything is working much faster. But I really need to don't do that because I create a computed column named driver ID. So actually I can do this and make it even more simple. And I'm still hitting the index seek here. So everything is working great. All right. The next one is temporal tables. Temporal tables are great if you are really caring about the history of your data. They are good for the auditing the data. If you have any kind of trending going on, if you have graphs and other stuff, they are good for that. When you do that, what actually really happens is we have the real-time tables. And if you turn them on, the temporal table on, that means SQL Server creates the same table. You can actually, if you want, it's optional, but you can change the name, the history table. And what happens is whenever you select the data, it comes from the real-time table. If you use any of the temporal table functions, then SQL Server is smart to actually join these two tables and get the data you are looking for. And every time there's an update, delete, and merge to this table, SQL Server actually moves that data, if it's necessary, to the history table. And they are very useful and very simple, really. So They introduced in 2016, and in 2017 there was a minor change. The biggest, I guess, the problem was with the 2016 version was if you make a big table a temporal table, it gets larger because you are tracking all the updates, all the deletes, everything. So, and usually the business has rules, like, for example, your business might say that after 2 years, I don't care about this data. And you have the retention periods. In 2016, you had to care about that yourself. In 2017, Microsoft actually add this option, and you can actually change it to any years here if you like. After 2 years, SQL Server will start to delete the data. So, and you don't need to do that manually. So that was the only difference between 2016 and 2017. So let's go and look at the SSMS here for this one. So as you can see in here, to make it a temporal table, all you need is 2 columns, date time 2 columns, and SQL Server is responsible for these 2 tables. And I'm making the system version is on, and this is optional. If you want, you can give a name. If not, SQL Server will give a name for you. So it will be more user-friendly in this way. And the next one is 2017. Really, the only difference here, as I said before, you can have a retention period here, and it will make your life much easier later. So if I run that, then really it's the same thing, start date and end date the same. And this is the one which is actually, you are telling SQL Server which columns to use for the temporal functions. Now I have some other functions here that I can actually show you from the temporal. So in here, what I'm doing is I'm just using this for system as of. So when I run this, it just shows me what my data look like. It looks like this was my data. You can use the contain in, and if I run that one, it looks like my data changed 3 times between those 2 dates. And you can use the between, and you end up with different. So as you can see, the rule is here. The difference really mostly is equal and larger, or larger than equal. So that's the only difference between those, really the special names, I guess. And you can actually have the all rows if you want to see all of them. SQL Server will join both tables, and it will give you all the changes that you want to see. So that's the temporal tables. They can be really, really useful. I use them mostly in my lookup tables. They don't put them in a big tables. In lookup tables, it's kind of nice to see what is actually changing, and I like this. All right, the next, which is the last one here, is clustered Columnstore indexes. Clustered Columnstore indexes has been out there for some time. So when you actually use them in a table, SQL Server compresses your data and indexes your data, the whole data table. And whenever you try to, and it indexes those tables by columns, not the rows. So usually for OLTP, you need to kind of do it by the row store, but when you analyze it, it really doesn't help you that much. So they are mostly for analyzing the data. Also, let's say you have 20 columns in your table, and you're in your select statement, you are only using 2 columns. SQL Server is smart enough to actually eliminate 18 of them, and it will only get 2 of them, and it will look only at 2 areas to give you the data that we are looking for. You need to be careful with them because they don't support all the data types. For example, I don't think they support any geospatial data. Var binary, I think, which I'm not sure, but I think var binary is supported in 2019. In 2019, actually, online index is available. In 2017, it wasn't like that. So 2019 is much better to use them cluster Columnstore indexes. So you don't need to, I guess, stop anything to re-index them. All right, so next one here, I want to give you, I guess, what they can do for you. So as you might remember, this kind of structure we just did with the JSON object NoSQL. So it's the same data structure. The only difference is the index type. The first one is a just regular non-clustered index for invoice ID. The other one has a clustered column store. What I'm doing here next is inserting the same exact data to the both tables. and I have 3.5 million JSON documents in those tables. Look at the big change, especially the data size. One of them is 2.5 gig, other one is 254 megabytes. That's a huge change. That means your data is smaller with cluster Columnstore indexes. So it might be actually, you might be able to find the data you are looking for much, well, faster. But can we? Well, let's run some kind of crazy query here. Look at my query. I'm doing everything that I should not do. I have an aggregation, I have casting, I'm using JSON functions, and on top of that, I have the group by. So, and I'm doing that for 3.5 million JSON documents. And if you look at the actual numbers here, I run this probably like 20-25 times, and that's the kind of overall number. With no cluster Columnstore index, the left side runs this almost like 40 seconds. Right side though is 11 seconds, and that's pretty crazy column. I mean, pretty crazy query to run, and I'm kind of happy with what I see here. This can be really used in many ways. I kind of compare the structure to Cosmos DB, because if you think about the Cosmos DB, you have the NoSQL, area, and you kind of query by, well, it's kind of almost like a T-SQL language, and you end up with JSON objects. So this kind of, I can compare this to Cosmos DB. It doesn't have all the stuff Cosmos DB comes up with, but you can create NoSQL environments just like that by CCI support. So I like it. Well, I think I did good, 57 minutes, and thank you for attending to my session today. If you have any questions, please ask me from Twitter or LinkedIn, and check my Blogspot blogger. I just like to blog at least once a week out there. And lately I'm writing a lot about the Cosmos DB. So I hope everybody learned something new today. Thank you.
Thank you very much, Hasan. That was very good.
Thank you.
There's no questions at the moment, but so nobody has posted anything.
All right.
Oh my God, I don't see anything coming in. Our next session will be coming up at 3:30, so hopefully we'll see some of you there. And in the meantime, please go take another look at sponsors. Make sure you get in for the raffles, all that good stuff. And we have one session to go today, so take care, everyone. And I think that'll do it. Oh, just great thanks came in, Hasan. So.
Yep, thank you. And also thank you everybody and sponsors too. And thank you for selecting me.
Yeah, absolutely. Yeah, it was a very good session.
Thank you.
Yep. All right, well, take care and we'll see you somewhere down the road.
Yep, thank you very much.
All right.